This is the mad scientist back in the game conducting our test 2 in trial 2, which is springs. And today is Friday, January 27, 2012, as I said in the test before, and it is 4 o'clock right now.
And as we already did this pre to the experiment, we measured the mass already. As you can see, it's kind of blurry, but the egg's mass was 53.1 grams, and the saran mass was 1.1 grams.
So right now, we will wrap this egg in saran wrap.
And just in case you don't know what saran wrap is, this is
it's clear wrap,
yeah.
basically. And we will trial to test you on it so that it shows that we are not using the same egg.
And there are no cracks or markings, so that you can see this isn't the same egg. So this is just some duct tape that we created. So I'm just gonna focus the camera a little bit.
So as we did in the test before, we'll be focusing on the calculator.
Yes, and we'll be using the same materials. So the added feature, as you can see on the car, there. The added feature is a spring. Can't really see that, and we'll just be focusing on the calculator because the movement moves really fast. So we don't want you to assume that it was just saved. So we'll focus in on the camera as my partner puts it down after she saves the last one.
Okay, so we have the graph on right now.
And let me just focus.
And then we'll put the egg that was wrapped in saran wrap in the blue physics card that we borrowed, making sure that the sensor lines up with at the same time as the springs touch the wall.
And as you can see, the graph is blank right now. So we'll just prepare the car with the same egg and with duct tape. And we'll just use the same contraption of 4 springs. And if there's a noise behind, like somewhat like last time, but louder and the car going, so that can just serve and as that. So right now we're just going.
Okay, so right now we'll be conducting the experiment.
And my partner will get the calculator ready. So
I'll have the wire come out of the way, and then we get ready. 1, 2, 3. 1, 2, 3. So we push this right now, and you can see, that it has a bunch of lines, and my partner will push the lowest point on the graph right now. And then it says that the force was 12.799 newtons again, and that the left time was 0.54 seconds because we have to take the whole number off, which was a 4. So right now,
my partner examines the egg. I will be calculating
the velocity
and acceleration. And I'll explain it in just a few seconds as I zoom out.
So we'll carefully take this off, and then we will unwrap the egg. It seems that it is leaking a lot. Okay, so we'll just basically do a close-up on this because it's leaking really badly. So as you can see, the saran wrap is sticking to the egg, and there is a huge crack.
And as my partner holds it for a while, so the camera can focus in,
Also, there are many minor cracks next to the huge crack right now.
And if
We'll try to separate it a little bit, and you can see the inside.
Wait. So just a few seconds.
And to show that it's actually leaking, if you touch it, it's all sticky.
Well, it's very blurry right now, so I'm trying to get it to focus. There. And my partner will just hold it there. And as you can see, it's like crushed completely. So it might be the motion sensor, but it didn't happen before. So with the other trial, so we're just thinking that it might be in the impact. And since we moved the cars, you can't see it, but it did bounce back a lot. And since it's leaking, we'll keep the saran wrap on,
and then we'll measure the mass of the egg right now.
I'll just calculate the velocity, and my partner will bring the triple beam balance over so you can see what we're doing.
Right now, it's sideways so that I can actually measure the egg's mass. But as soon as I measure it, I will turn it towards you.
Okay, let me just zoom out so you can see what's
So I'll start measuring right now. It isn't heavier than before, which was 50. It's around. So the line is lining up right now, but it's a little bit heavy. So we'll move it back about. Oh, great. 0.1 grams. So right now we have the total mass of the egg, and I will show it to you. And I will also tell my partner that the mass of the egg is 53.95. And then she will subtract this saran wrap, which was 1.1 grams in the beginning. And I'll turn this towards you. So get this out of the way. So if you can actually see it, the egg is placed right here on top. And then
as we subtract it, it's 52.85 grams. So it had lost a lot of mass by 1 gram. Usually it's just point something, but this time it's actually 1. So and my friend here is saving it as I calculate the velocity, and basically it's displacement over last time, so it's 18 over 0.54, and we'll use a calculator.
Meanwhile, I will be saving the graph for safekeeping inside the calculator that we're actually doing using now.
And the velocity is 33.3 repeating. And we'll just take that, which is our velocity, and divide that again by our elapsed time, which was 0.54, which is, this will give us our acceleration, and that equals 61.728,394. So that's really great acceleration, and also we're going to write some qualitative data down. So I put huge crack leaking, car bounced back.
So right now, in case it begins to leak outside the saran wrap, we will wrap it in another sheet of saran wrap, and we will also store it somewhere else so that it does not get all over or leak all over our science tools.
And basically that concludes our test 2 for trial
2, which is springs. Thank you.
Thank you.
Bye.
Bye.